This is Xiangshi from Center for Human Engaged Computing in Kochi University of Technology. Today I will introduce about the technique we designed for facilitating text revision on mobile devices. This work was done with Sayan Sarcar from the University of Tsukuba, Sunjun Kim from University of Finland, and DGIS Republic of Korea, and Xiangshi from Kochi University of Technology. Nowadays, mobile devices are dominant tools that we cannot avoid. According to the report from Pew Research Center, 15.2 million of messages are sent a minute, and 48% of emails are opened and dealt on devices such as smartphones and tablets. Usually, we don't type on the smartphone just for fun. Of course, we always chase for faster typing speed, but it should be reminded that we are not typing for typing. Instead, we type for expressing emotions, describing new ideas, or achieving agreements with other people. In those cases, we are required to ensure the text with both correct spelling and proper meaning for scenarios. However, we cannot avoid making mistakes. We often make typos during the text entry and we have to correct it. There is also the condition that all texts are typo-free but with improper meaning, which may cause embarrassment or misunderstanding if we don't revise them. To finish the revision, we have backspace and caret, which are inherited from a physical keyboard and mouse. However, due to the fat finger problem and the repetitive use of backspace, it is error-prone and time-consuming to revise text on mobile devices with those tools. For further understanding the typing behavior, Arif proposed a model to describe the text entry process and divide it into multiple steps. For enhancing the error correction efficiency, researchers focus on the specific step and design the techniques accordingly, such as auto-aids, prediction lists, matching mechanisms, gestures, and magnifiers. We further analyzed the correction step and found that there are three main types of revision. In smartphone typing, those types of revision may lead to various operation procedures with frequent use of backspace and cursor control. For instance, this girl wanted to type "I want to join the party," but she already entered "will not" on the smartphone. So how could she revise that? Usually we have two solutions. One is to use the backspace only. We use 90 retype intent. The other is the so. First, move the cursor with 4 backspace to delete and to the end and finish. These two solutions fit the need of text revision, but bring the time consumption operations to facilitate users' text revision on mobile devices. We want to find out the efficient approach to revise text on mobile devices with less use of backspace and less of using cursor control. We got inspired from the revision marks used in the pen on paper revision. For example, we can use the symbol to delete, insert, or replace words in this sentence. It is intuitive to see the changes. We summarized the commonality of those marks and found that most revision requirements could be unified as the replacement. With this idea, we can change, delete, insert, and substitute into the unified replacement options. It's understand in mind, but implement in the current mobile text-entry system. Because we don't have the visualized deletion function which can appear on the screen just like regular characters. We use the iterative design in this study to validate and enrich our technique. Prototype, we use dot to symbolize the deletion rule of using dot to turn insert a word as the replacement. We allow users to enter the content at the end of the and use it for replacement. Through a within-subject text revision task, we compare the performance of our prototype with the conventional backspace and caret and the magnifier, which is now used in most Android and iOS devices to enlarge the area under the fingertip. Results show that dot swap use significantly less cursor control number and less time consumption during the revision process than other two techniques. For other two techniques, magnifier could use the number of cursor control, but it cannot show better time saving compared with the conventional backspace and cursor control. Our prototype also used significantly less number of backspace than other two techniques. Through the feasibility of replacement-based text revision in reducing the use of backspace and caret control, but also found problem on users' feedback for further improvement. Extra cognitive load is needed to remember the rules of using the dot. Second, it brings confusion to users when the dot is given multiple meanings. We improved our design to those problems. When you're entering extended layout will be called out, words and gaps among individual units, then users can tap the corresponding. After that, the cursor will remain at the end of the string for further input. Additionally, we implemented the deletion function on the keyboard as shown in the picture. The changes above visualize the deletion function and the gaps among words for easier selection. We also integrated the cancel button in the expanded layout to withdraw the wrong callout. When entering the deletion function, it will appear up on the screen. Then users can use it for replacement. Design a within-subject paragraph revision task to compare users' text revision performance with the conventional backspace and cursor control. We ask users to revise 6 paragraphs as fast as possible with each technique. We put 8 revision targets in each paragraph. We include both character level and word level targets for insertion, omission, and substitution in each level. Results show that compared with the conventional backspace and cursor control, improved swap got significant less number of caret control and less time consumptions among all types of revision targets. We also measured the typing speed during the revision and found that improved swap could reach an average of 124 and 0.55 keystroke per minute, which is significantly faster than the conventional technique. We also used a 7-scale questionnaire to collect users' subjective feedback. Results reveal that the improved swap was easy to learn and easy to use with less fatigue. Usually, When users found targets to revise, they need to stop their regular typing and switch to the process of using backspace and cursor, and then switch back to regular typing. This behavior ruined the fluid typing and thus reduced the typing speed. But our technique avoids the repetitive use of backspace and cursor control and enables users to keep on typing with their regular typing speed when they found the target. Thus, it could improve the overall text revision performance. In the summary, we provide a new perspective to reconsider the mobile text revision tools and processes, and a technique for facilitating text revision based on the unified replacement thinking. For future work, we will combine the current auto-ace techniques, such as machine learning, with our idea to realize the flexible granularity replacement. Thanks for your attention.